we'll start with number 2. Particle rest mass m0 relative speed of this. At what speed will its momentum be quadrupled? Alright, so right away, I should, let's see, just make sure I know what quadrupled means, if you're not clear on that, so, let's see. So, I'm going to put things, let's see, my y is set around like C is fixed from all frames of reference, but momentum is relative, since inertia and velocity are relative. And I should also note that probably that momentum increases relativistically. Oh, I didn't check your Y's. Let me come around and do that before we, Alright, so back at what we were doing here. So, mine is quadrupled, which means I'm looking for it to increase 4 times as great. So I'm going to grab my equations, and my momentum equation is right over here. And I will need my Lorentz transformation. Then, therefore, let's see, let's get back here. So, I want my momentum at whatever velocity this is, so I'm going to call it P2, to equal 4 times whatever my, let's see, let me make sure I get trying to speed this. With one speed, will its momentum be quadrupled? So I want it to be 4 times whatever my momentum is at the first case. Alright? So I'm looking for my momentum to increase, be 4 times as great. And so I'm going to, the U is, remember, is just the velocity relative to the frame that I'm measuring it in. So P2 is going to be gamma 2 rest mass U2, and that's going to equal 4 times gamma 1 rest mass, which they told me was m0, and U1. Right away, hopefully you see that the m's cancel out, and I'm left with whatever my U2 is over square root of 1 minus U2 over C squared equals 4 times my U1, which for me is 0.23 C, over square root of 1 minus 0.23 C over C quantity squared. Again, I would rather solve for U2 over C than just for U2. So my mathematical step will be to get to solve for U2 over C. If I do that and I divide both sides by C, I get U2 over C divided by square root of 1 minus U2 over C squared equals 4 times 0.23, because the C's cancel out, over the square root of 1 minus 0.23 squared. And either algebraically or using Wolfram, solve for U2 over C. You know, put it in as the variable X or however you want to solve for it. I'll solve and make sure, since it's Tuesday morning, make sure it works, but you try it too, and if you need help with the math, call me over. Guys, just realize I am recording. It probably doesn't pick up your conversation. So I get 0.687. Let's see. Alright, so we're going to talk about number 4. Actually, the idea behind number 4 is a couple of different things I want to show your understanding of. One is the equivalence principle that we talked about yesterday, and showing that you understand what power is, which is a good thing also. So, especially since it will be on the exam coming up. So this is number 4. You want to show that you understand what the equivalence principle is. The way I'm going to do that is by recognizing that matter is a condensed form of energy. And also showing that I understand power is the light bulb will use electrical energy. And power is the rate energy is being used. So I've shown that I understand the relationship between matter or mass and energy. I've shown that I understand the light bulb uses this form of energy, and that power is the rate that that light bulb is going to use. Those are the key concepts in this problem. Equation-wise, don't feel like flipping back. I'm going to use that E equals mc squared. I'm going to use that power is the rate of energy, so energy per time. All right. And so I am told that this bulb has a power of 110 watts, which is 110 joules every second. I'm told the time we're looking at is 3 years. So I can either change from my joules per second, my watts, to joules per year, or change my years to seconds. Whichever way makes sense to you. All right? But I need to say, okay, if it's running for this amount of time, it's going to use this much energy. So the power multiplied by the time is going to give me the energy. But I need to make sure that these two are in compatible units. Power, joules per second times seconds, or joules per year times years, whatever, however that works out. All right. And once I know that total amount of energy, I'm going to use the mass energy equivalence here to solve that. So I'm going to have the power multiplied by the time in my correct units. That's going to be the amount of mass times our ratio there, c squared. So rearranging that, pt over c squared equals the amount of mass that will have to be converted to its other form, in other words, to fulfill this light bulb's need. So make sure that power and that time are in correct equivalent units. Personally, what I would do is change the time to seconds. You can either do that, through like Google or on your calculator. And then, you should have C stored in your calculator. If not, it's on our equation sheet. And a couple multiplications and you're there. Going to be a large amount of mass or a little amount of mass? What do you think? Little, tiny amount. Tiny amount. That's what you should expect. Folks, one unit concern here besides the time there is that this mass that you get when you finally solve here, say mass equals blah, 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 that's going to be in kilograms because that's our base unit. But notice the prom mass for it in grams. So you'll need to make sure you convert from kilograms to grams before you put your answer in. Because that can be very frustrating. All right, so we're doing number 5 here. You've got an explosion of a star, and if this is this much energy, and how many kilograms of mass converted energy in this explosion? All right, so this one is saying, hey, do you remember that matter and energy are the same stuff? That's what it's all about. So equation-wise, we're looking at that E mc squared. And let's see, we're told that this much energy is produced. So that would be our E, and nicely it's in joules. And then we're asked to find the amount of mass that would do that. So basically you put in your value for E, you know C squared, and you solve for M. And your answer will be in kilograms, which I believe is what they asked for. And then all you're doing in part B is putting your answer for part A divided by the mass they give you in the question. And you're done. Yay! Let me know if you need help individually with the mathematics involved in this one.